Have you ever pondered whether we're truly alone in the universe, or if there's something more to our existence than what we see? Imagine a scenario in which the James Webb Telescope finally reveals that we live inside a black hole. Join us as we explore more about this groundbreaking news that will make you question everything you thought you knew about the universe. So, what exactly are black holes? They're like something out of a nightmare. Sure, you might have seen them in sci-fi movies, but they're far more terrifying in reality. According to scientists, black holes are essentially enormous amounts of matter compressed into an incredibly small region. Imagine a star many times more massive than the Sun, packed into a sphere the size of New York City. The gravitational pull is so intense that nothing, not even light, can escape from it. Scientists have been fascinated by black holes for a long time. They've studied objects in space so massive and dense that they can trap light. The most famous theories about black holes were predicted by Einstein's theory of general relativity. When a massive star collapses, it leaves behind a dense core. If this core's mass is several times that of the Sun, gravity overwhelms everything else, leading to the formation of a black hole. Detecting black holes is no simple task, since they emit no light. However, experts have found ways to infer their presence by observing their effects on nearby matter. For example, if a black hole passes through a cloud of interstellar matter, it will pull that matter towards it in a process called accretion. Moreover, when a normal star gets too close to a black hole, it can be destroyed, emitting X-rays as it does so. Black holes also have a significant impact on their surroundings. They can devour nearby stars, release powerful bursts of energy, and even influence the formation of new stars. But where do black holes come from? Picture stars, once brilliant and blazing, meeting their dramatic end in a spectacular explosion called a supernova. From the remnants of these fallen giants, black holes emerge. Most black holes are born from massive stars that have reached the end of their stellar lives. Smaller stars, when they die, turn into neutron stars, extremely dense, but not dense enough to trap light. However, if a star is many times the mass of our Sun, it collapses under its own gravitational pull, forming a black hole. Near a black hole's surface, time itself starts behaving strangely. From the perspective of someone far away, time appears to slow down near the event horizon, the point of no return for anything falling into a black hole. Sometimes, when two smaller black holes collide, they merge to form an even larger and more terrifying black hole. If a black hole interacts with a neutron star, the result is a cosmic nightmare that defies comprehension. Researchers have been grappling with the immense scale of these phenomena for years. Black holes come in two sizes, large and small. However, small is relative when it comes to black holes. The remnants of giant stars can be 10 to 100 times the mass of the Sun. There could be as many as 10 million to a billion of these in the Milky Way alone. But wait, there's something even more colossal. Supermassive black holes are millions, if not billions, of times larger than the Sun. They exist at the center of massive galaxies, including our own Milky Way, pulling everything towards them with their immense gravity. The renowned physicist Stephen Hawking spoke extensively about black holes. While some of his theories couldn't be confirmed due to a lack of advanced equipment, hope is on the horizon. Enter the James Webb Space Telescope, JWSD, an engineering marvel that's transforming our understanding of the universe. Unlike previous space telescopes, the JWSD is an extraordinary feat of human ambition, costing an astonishing $10 billion. It's the result of collaboration between NASA, the European Space Agency, and the Canadian Space Agency, along with contributions from over 300 universities. Despite the risks of such an ambitious project, the JWSD has already achieved incredible milestones. It has traveled over 1 million miles to its orbit around the Sun, where it will remain indefinitely. After successfully deploying its massive sunshield and primary mirror, NASA announced that the telescope has enough fuel to last more than twice its expected mission lifespan. One of the JWSD's most exciting moments came when NASA released its first images of starlight. The telescope captured a star called HD 8446, creating a mosaic of 18 scattered bright spots. These spots were later aligned into a clear, hexagonal image. Thanks to its cutting-edge technology, the JWSD will help scientists study the early stages of the universe, right after the Big Bang. It will also search for exoplanets and analyze their atmospheres, potentially identifying habitable worlds. The JWSD is also examining galaxies to understand how matter is organized on a large scale and how the universe evolved. Most importantly, it may help answer the fundamental questions. Are we alone in the universe? Are we living inside a black hole? Recently, the JWSD detected polycyclic aromatic hydrocarbons, PAHs, near supermassive black holes in 3 active galaxies. These carbon-based molecules, which could be building blocks of life, help astronomers track star formation. However, near these black holes, radiation altered the PAHs, transforming them into larger, electrically neutral versions. This discovery raises profound questions about the nature of our existence and the true structure of the universe. Ultimately, the JWSD is pushing the boundaries of human knowledge, bringing us closer to understanding whether we truly exist as we perceive, or if we are part of a much larger cosmic mystery. As the James Webb Space Telescope JWSD continues its mission, it's not just unraveling the mysteries of black holes and star formation, but also delving into fundamental questions about the fabric of reality itself. The data it gathers could lead to groundbreaking discoveries that challenge our current understanding of physics, time, and space. One of the most tantalizing ideas is a possibility that our entire universe might exist within a black hole. This concept, though speculative, is supported by some theoretical physicists who suggest that the universe's observable characteristics might align with the internal structure of a black hole in a higher dimensional space. According to this hypothesis, the event horizon of a black hole could serve as a boundary between different universes, with our own universe existing as a bubble inside it. If this is true, the implications are staggering. Everything we experience could be part of a much larger cosmic structure beyond our comprehension. The role of the JWSD in exploring the early universe. The JWSD's ability to peer back in time, to the first few 100 million years after the Big Bang, is crucial for answering these existential questions. By capturing infrared light from ancient galaxies, the telescope allows scientists to observe the universe in its infancy. This period, known as the Cosmic Dawn, marked the formation of the first stars and galaxies, which emitted light that has traveled billions of years to reach us. By analyzing this light, researchers hope to understand how the first cosmic structures formed and how they evolved into the complex universe we see today. Could these early structures hold clues about the true nature of black holes, or even support the hypothesis that our universe is inside one? Probing exoplanets for signs of life. Another groundbreaking aspect of the JWSD's mission is its search for life beyond Earth. Its advanced instruments can detect the chemical compositions of exoplanet atmospheres, looking for biosignatures, molecules that might indicate the presence of life. For example, the discovery of oxygen, methane, or water vapor in an exoplanet's atmosphere could suggest that the planet is habitable or even inhabited. Recently, the JWSD detected carbon dioxide on an exoplanet named WASP-39b, a significant step in understanding the atmospheres of distant worlds. Future observations might reveal more complex molecules, potentially pointing to life forms far beyond our solar system. If life is detected elsewhere, it would fundamentally alter our understanding of our place in the cosmos and support the idea that life is a common phenomenon in the universe. Challenges and future prospects. Despite its incredible capabilities, the JWSD faces significant challenges. Its observations must be meticulously calibrated to filter out interference from our own solar system and galaxy. Moreover, interpreting the vast amounts of data it generates requires advanced computational models and collaborative efforts from scientists worldwide. Looking ahead, Future missions could build on the JWSD's discoveries. Proposed projects like the Habitable Worlds Observatory, HWO, aim to search for Earth-like planets around Sun-like stars, while next-generation gravitational wave detectors could provide new insights into black hole mergers and the structure of space-time. The big picture. What does it all mean? The discoveries made by the JWSD are more than just scientific milestones. They touch on profound philosophical questions about existence, reality, and our place in the universe. If we find evidence that our universe is inside a black hole, or if we detect life on other planets, it would challenge many of our assumptions about reality. Are we part of a multiverse, with countless other universes existing beyond our own? Is the structure of the cosmos far more complex than we've ever imagined? As the JWSD continues its journey, it invites us all to ponder these questions and embrace the wonder and mystery of the universe. Each new discovery brings us closer to understanding the cosmos, but it also reminds us of how much we still have to learn. In the end, the quest for knowledge is a journey without a final destination, a journey that continues to inspire and awe as we peer into the depths of space and time, searching for answers to questions that may define the future of humanity.